In this video, I'm going to try and solve the differential linear equation dy over dt plus 2y equals e to the power of t over 3. First things first, we have to understand that the linear equation in this scenario is dy over dt equals negative 2y plus e to the power of t thirds, whereas the homogeneous equation is dy over dt equals negative 2y. Now the easy part was solving the homogeneous equation. All I had to do was use separation of variables to conclude that the solution is yh of t equals a constant times e to the power of negative 2t. Now that we have that information, it's time to move on to the next step. You may notice that the initial condition states that the derivative of some y function shall equal negative 2 times that y plus e to the power of t over 3. So, what exactly is that y? What y value will make this equation work? What about e to the power of t thirds? I mean, that's already in the initial condition. Will that value work? No. Plugging that solution into the condition gives us something close, but it's the wrong constant. So we can say that is not a solution. To find the actual solution, we might as well multiply it by a constant term a and see where that gets us. Like before, I'm going to plug this into the initial condition, and we can see that leads us to 7 thirds a e to the power of t thirds equals 1 e to the power of t thirds. And with a little division, I concluded that our constant a value equals 3/7. So we can substitute 3/7 for a, and now we have a possible solution. But we have to check to see if this works. Does this solution work? Yes! We can see that by plugging this solution back into the initial condition, we are left with e to the power of t thirds. So this is a solution. So now we have that the function yp of t equals 3/7 e to the power of t thirds. And going back into the niceness theorem, which we went over the other day, all we have to do to find the general solution is add the two together. Meaning that the general solution is y of t equals 3/7 e to the power of t thirds plus c e to the power of negative 2t. Now all we have to do is come up with a specific solution under the condition that y of t equals 0 equals 1. First, all I had to do was plug in 1 for y and 0 for t wherever they were found in the equation. Next, using the properties of the number 0 and exponent rules, I can conclude that we're left with e to the power of 0, which equals 1, so we can just get rid of the e's. So now I'm left with just constant terms. 1 equals 3/7 plus c. And with simple subtraction, I've concluded that c equals 4/7. So we can say that the final specific solution is y of t equals 3/7 e to the power of t thirds plus 4/7 e to the power of negative 2t.